Welcome back to linear algebra. Let's jump into Anki. What is the standard matrix for a reflection about the YZ plane in R3? Negative 1, 0, 0, 0, 1, 0, 0, 0, 1. What is the standard matrix for an orthogonal projection onto the y-axis in R2? 1, 0, 0, 1. No, I did not mean to say that, but I did it wrong anyway. Undo. That's wrong. What is the standard matrix for an orthogonal projection onto the XZ plane in R3? 0, 0, 0, 0, 1, 0, 0, 0, 0. What? All right, wrong again. What is the standard matrix for an orthogonal projection onto the YZ plane in R3? 0, 0, 0, 0, 1, 0, 0, 0, 1. What is the standard matrix for a reflection about the XY plane in R3? Reflection about the XY plane? One, 0, 0, 0, 1, 0, 0, 0, negative 1. What is the standard matrix for the linear operator that rotates each vector in R squared clockwise about the origin through an angle theta? Cosine sine, negative sine cosine. What is the standard matrix for an orthogonal projection onto the x-axis in R squared? 1, 0, 0, 1. Did not mean to say that again, but I'm going to say it's wrong anyway. What is the standard matrix for an orthogonal projection onto the xy plane in R cubed? 1, 0, 0, 0, 1, 0, 0, 0, 0. What is the standard matrix for a reflection about the xz plane in R cubed? 1, 0, 0, 0, negative 1, 0, 0, 0, 1. What is the standard matrix for an orthogonal projection onto the xz plane in R cubed? 1, 0, 0, 0, 0, 0, 0, 0, 1. What is the standard matrix for an orthogonal projection onto the x-axis in R squared? 1, 0, 0, 0. What is the standard matrix for an orthogonal projection onto the y-axis in R squared? 0, 0, 0, 1. All right. There we go. I'm going to go ahead and grade what I did yesterday then, and then I'll be back to recall how I did. All right, I missed one problem from yesterday. And I overthought it. I had it right originally. So, right, it says find a standard matrix for the stated composition in R squared. First, a rotation of 90 degrees. So forever, that's going to be on the left side, followed by a reflection about the line y equals x. So I should have done it this order. I flipped it around in the end. All right, so I'm going to continue doing more practice problems, then I'll be back to recall what I learned, what I did in a little bit. All right, we finished a few problems. 7a was about finding standard matrix given the equation. Well, how do you do that? The way I did it was finding the standard basis vectors and then partitioning them, and then same thing for the second one, same thing. Standard basis vectors, vector images, partition to do a standard matrix. And then from there, we're going to use those in part B to find T2 OTA. And so I took T2 times TA, T2 OT1, standard matrix from 2 times standard matrix from 1. There's that. And the same thing for T1 OT2. And then for part C, we're going to use those matrices, I think. So T1, and then this is T2 within there. I think this is the same thing as saying T10 T2. And so I took T10 T2 standard matrix we found in part B, multiplied that by the given vector to find that. And then the same thing here for T2 OT1. All right, and then 17 we started. This is really weird. It wasn't really something new. It basically said, what did it say, something about an operator, but it said put this in matrix form and then determine if the operator is invertible by basically finding if the reduced row echelon form is equal to I. And so that's what I'm in the process of doing here. So not quite done with that, but that's basically it for today. We're now moving through pretty good pace on 1.9 now that we're done with those Anki flashcards for 1.8. 1.9, it doesn't have that many exercises actually. So we're not too many days away from 1.10, which is really cool because now then it will be into applications. So, and I'm seeing stuff about electrical chips, or electrical circuits, I mean. So that's very interesting. So that's it for today. Talk to you tomorrow. See you.